Let's first set up Arduino IDE with Firebase. Open Arduino. First of all, we need a library to connect our ESP8266 to Firebase. Download this library from https://libraries/thingsping-firebase.zip. The URL is shown on your screen. Save the zip file to your computer. From Arduino IDE, click on the Sketch menu. Choose Include Library option, and then click on Add.zip library. In the file dialog, choose the zip file which you just downloaded. You should now see a message which reads, Library added to your libraries. Check Include Library menu. Now say File, New. A new Arduino sketch is created. Say File, Save. It will ask you where you want to save. Choose the correct directory and give an appropriate name. Say Firebase Trial. Now click on Save. We are now ready to start writing the actual code. The first step is to import the newly added library. Click on Sketch, Include Library. You should now see a menu option which reads Things Bing Firebase. Click on that. You should now see a bunch of items added at the top of the sketch. Now add two constants to connect to your router. Wi-Fi_SSID should hold the name of your wireless router. Wi-Fi_password should hold the SSID password of your wireless router. Now define two constants for the Firebase project name and the database key. Let's recap the steps. For getting the project name and key, go to console.firebase.google.com. You should be able to see all your projects here. Pick the project which you created for the smart room and use this name. In Firebase console, select this project. Click on the settings gear icon next to project overview. Click on project settings. In the page that shows up, click on service accounts. Now click on the database secrets option. You will see the database name with a series of circles. Move your mouse over the database name. You will now see a show button. The actual database key should now be seen. Copy the secret key. So now that we have got all the required values, substitute these values in your constant definitions. When you paste the project URL into Arduino, remove the https:// part from the string. You should also remove trailing slash, if any. For example, in my case the value for Firebase_host is, smartroom7b77.firebase.io.com. Now define constants for the push button pin and the LED pin. Now let's get to the setup method. First initialize the serial port communication. And then define the pin modes. In the Firebase.yConnect line, we are trying to connect the ESP8266 to the wireless router. In the Firebase.begin function call, we are setting up the Firebase library with the Firebase project name and the database key. We will now write two more lines in the setup method to create initial values in the Firebase database. Firebase.setString pushButton, released, Firebase.setString LED, off. By giving these statements, we are making sure that the database has these initial values whenever the ESP8266 is powered on. That completes the setup method. Now let's see the code for the loop method. Firebase libraries getString method reads the value of the function parameter from the Firebase real-time database. We will then read the digital state of the push button. Then print out these values to the serial console. In the if-else block, we check if the text in the Firebase database is set to on. If yes, then we turn on the LED. Otherwise, we turn off the LED. In the above if condition block, we are first checking if string light status is set to on in Firebase. If yes, then we are making the digital state of the LED pin to low. To summarize, what we have done in the above lines of code is that we have read the value of a string from the Firebase real-time database, and based on the value of this string, we have either switched an LED to on or to off. In the next set of lines, we check if the push button is pressed or released. Based on the result, we update this value in the Firebase database. Finally, we'll have a delay for 1 second, before repeating these steps. To summarize, in our experiment we have A. Read the value of an attribute from Firebase database and based on the value, taken an action. B. Read the state of a pin on the ESP8266 and write to the Firebase database based on the value. So we have been able to write to the Firebase database and read from the Firebase database. So that's it. Let's compile, upload and check what happens. Before we execute the code, let's start with a clean copy of Firebase. On your web browser, go to console.firebase.google.com. Choose the project, which in this case, is SmartRoom something. Now click on the database link in the left navigation bar on the right-hand side, in case you see two options, one for Cloud Firestore and the other for Real-Time Database, then click on the Real-Time Database. If you now see that there are some entries already shown on the right-hand side, then clear all entries. To clear, simply click on the cross mark next to the project name. In the confirmation box, click on Delete. Now connect the USB port of the ESP8266 to your computer's USB port. Switch back to Arduino IDE. Click on the tick mark on the top left-hand corner. After a little while, you should see the message, Done compiling. Now click on the right arrow icon next to the tick mark icon. After a short time, you should see the message, Done uploading. Now navigate back to the web browser where your Firebase console is open. On the right-hand side pane, you should now see two entries. A. One that reads LED: off. B. One that reads push button: released. Now these two have appeared because of following two lines in the setup method, firebase.setString push button, released, firebase.setString LED, off. In the Firebase console browser, change the value of LED to on. In a second or so, you should now see that the small blue LED on the ESP8266 is turned on. On your breadboard setup, press the push button and keep it pressed. In a second or so, you should see the value of the push button key in the Firebase console has changed to pressed. Now release the push button. In a second or so, on the Firebase console you will see that the value of the push button has changed to push button: released. So you have written your first IoT code. You were able to send the push button state of your ESP8266 to the cloud. And, you were able to control the onboard LED from the cloud. Congrats! Let's move on to the next section.